start if we want to be in time this session. Good morning, everybody, and thank you to be here so early after 3 days of wine, French wine, and then food. And we start today the session number 3. And my name is Daniele Pinti. I am a professor at the Geotop Research Center for Geodynamics and Geochemistry in Montreal, Canada. I am a co-chair at this session with Frances Westall from the Institute of Biophysique Moléculaire of Orléans, France. And so, can we move to, I have a small presentation that I prepare for non-geologists, for our colleagues, astrophysicists, chemists, and biologists, about why the geologists are here and what kind of question they ask us, and we try to answer, and what is the status of early Earth geology today and where we can go further. So Muriel asked me, and I would like to thank Muriel Robert Pascal for inviting me here at this meeting. They asked me to have a real geological section and not something more related to the microfossil or something. This was yesterday's section that was presented by Barbara. Why geologists are here? So, because as was discussed yesterday at the panel in the afternoon of Antonio, by somebody make a question, is that we should try to answer several questions, like give a better picture of the geological environment in which life appeared and evolved. And we should be able to give some estimation. We have a presentation today about that, of the flux of energy that is between the surface envelope of the Earth, like the geosphere, the hydrosphere, or the atmosphere, that are potentially available to the first metabolism. So this is a very important point for non-geologists. And yesterday, one woman asked to the people to the panel that was managed by Antonio why they don't fit the RNA award in a geological framework. And this is simple because it's very difficult, but it's very important from them. And this intervention yesterday, remember me another, done by Guy Horisson, that was a very famous biochemist in France. At my first astrobiological research school, where in 2001 I was invited by Muriel, and there was a very strong debate. Again, it was mostly the same than yesterday about people that say that before came RNA, others that say there was DNA and the proteins, etc. I'm sorry, my souvenir of biology is in the 70s, so I'm a little bit rusty about that. And we were discussing about the fact that there should be some mineral substratum where they can do this kind of RNA can develop. And Guy at a certain moment get angry and say, well, where the hell they are the geologists? Why they don't give our answer? We don't give answer because you just ask us a very simple question. How was the Earth when the prebiotic world moved to a biotic one? And we show you with just 2 or 3 pictures of fieldworks that this is not easy task. So it's not really a simple question. This is, you can find in any kind of public school, is a geological time scale. You go from modern time back to time. This is showing just the evolution of life, and you see that life, you can find less and less life record in the geological record. This is for 2 reasons, because probably biosphere was not so abundant like today, but also for another simple reason, that at the same time, you are rarefying the geological record. We have less rock we can work, and as you chemists or biologists, you need the living matter to do your experiment. We need the rocks to understand how the Earths work. So this is a simple picture of the today continents, and the dotted areas, like here or here, is the only Archean terrain. So Archean don't mean so much because it covers mostly 1/3 of the Earth history from 3.9 to 2.5 billion years. So if you ask where is the two oldest terrains, well, we reduced this to this small part, Ijua. Munich Rosing, that will be the first keynote speaker, is a specialist of this area that is, will correct me, maybe around 200 kilometers long or something, so very small area. The second one is northern Quebec that was discovered by our research group around 10 years ago that have an age comparable around 3.9 billion years. So this is the two oldest pieces of the Earth that we have now on our surface that we can do experiments. The terrains where we work is not very easily, so mostly of you flew through Montpellier and they can see very beautiful canyons arriving here and quite simple geology. From the morphology also non-geologists can understand there is a young terrains, this is moving. You can see far the Western Alps, they are still building up. And this is the kind of geology I was instructed for example. When I started 27 years ago studying geology in the University of Rome, I studied like Alps, so it's very easy for a geologist. But when you go in this kind of terrain, sometimes it's quite flat, desertic area. The rocks looks everything except the rocks you study at school. This is a very nice picture view of the Komati River Gorge in South Africa, Barberton, 3.5 billion years ago. Geologists get quickly lost. Here we have Frances, our co-chair, that the younger one of the two in the picture using an older system, just a geological map to understand where we are. Nick Carter here, the elder one using modern technology, GPS, and the student, they are not so much bothered by life. They just stay in the car waiting that their master find the point where we are searching for. Sometimes outcrops are just few meters, and often the bigger criticism we receive by our colleague is that we try to explain the world, to 12,000 kilometers diameter world, with just 100 meters outcrops. You start to look at strange things. Now, actually, maybe this figure was on the other side. This is around 100, 200 meters of oceanic sequence of 3.5 billion years ago in South Africa. And you can see strange things like this. It looks like rigid layers that has been blown off by some kind of gas vent and then fossilized in that position. Quite strange. I never saw this kind of stuff in more modern rocks. But you can see also things that are much more familiar. This is this one. You can see this strange figure on this sandstone that is fossilized. And this is what we call gross bedding that is produced by hydraulic charge by a marine current in the bottom ocean floor. So if you find this at 3.5, we are sure that there is a liquid water on the Earth that teach us something more important. So after several years, we come up with some kind of picture. We stuck a long time on this famous picture. I think she's in the Smithsonian Institute. And probably there are things that are wrong in this picture. We can ask if at 3.5 there were stromatolites or not. I suppose that the talk of the second keynote speaker of Halwood probably will speak about also stromatolites. But it's true that this is more close to what we was the Archean world. When I started to study geology, as I said, mostly 30 years ago, it was a completely different picture. We really think the Aegean, that is come from the name of the Adeus, that is the god, the Greek god of the hell, it was really a magma oceans with volcanoes, fire, everything's impossible to have life. In 10, 15 years, we completely changed our idea thanks to new discoveries. So this is, I think, is the second most important revolution in Earth science after plate tectonics. And we understand that probably early Earth, it was quite cool early Earth with oceans and probably habitat that was sufficiently cold and habitable for life. And of course, still there are debates. So if in this room I will ask what was the color of the sky, probably Jim Casting will answer is red because it was full of CO2, and probably Yoshimoto will say no, it's blue because it was full of oxygen. There is still debates going on, but I think these debates are very important because they spark new research and trying to understand how was really the Earth. The problem is if I should answer to Guy, but unfortunately he died, or the woman yesterday make the question about NRN word, they need something different, because if I well understood in the several years I followed this kind of astrobiological conference, a planet like the Earth is probably quickly colonized by life. That means that probably you need to know how was the picture of the Earth in this moment, maybe 4.3 billion years ago. The moon was closed, it was just formed a few 10 of millions years before by an impact of a planet with the Earth. It's still impact. Today, Christian Kobel will discuss about the impacts on the Earth. Maybe it was really red, the sky, and full of CO2 and already an oceans. And this we cannot give you clues because we have no geological record of this so far world. I hope that in this session will give you some new clue, because all the geologists with our rocks cannot do nothing, but new geologists like Munich, using thermodynamics and also fieldwork terrains, they can try to make some model, explain you how was this change between prebiotic world and biotic world. So before to move to the first keynote speaker, just 2 or 3 slides. I would like to advertise something if I can. The first, I received this mail from Robert Pascal. And just to remember, we are organizing our research center, the Goldschmidt Conference, next year in Montreal. That is the most important geochemical meeting that every year is 1 year in North America, 1 year in Europe. And so you are welcome to come, because we have, is at the end of June, we have a team, we have 13 scientific team. The number 2 is about astrobiology, and Jim Casting and Dr. Ueno, they accepted kindly to be the president, the conveners of this team. And we opened the section from September 12th, so if you want to submit some section about astrobiology, you are warmly welcome. You can find on internet. You just write Goldschmidt and Montreal, and the first that appear is not a Wikipedia, because historically there is no logic connection between Felix Goldschmidt, the inventor of geochemistry, and Montreal. So you will find news about this meeting, and everybody is welcome. So thank you for your attention, and I invite the first speaker, that is Munich Rosing from Denmark, that he will speak to us about the early Archean biosphere, the invention of photosynthesis, and the destruction of the prebiotic environment. Thank you very much.